Hello friends, here we are going to discuss about the universal shift registers. So on completion of this universal shift register, the students will be able to analyze the timing of the sequential circuits and they can able to ensure the clock signal which is common to this pipeline registers. So in this universal shift register, they can be learning about the approach that they are used to optimize the sequential circuits. So first we can see about the pipelining. So pipelining is a popular technique which is used for accelerating the operation of the data parts in the digital processors. So with this idea which is explained is in the form of the example. So here you can see about the registers and the log clock pulses. So in the pipelining, an approach which we are used to optimize the sequential circuits is it is used to compute the logarithmic function of the two inputs where A and B represent the stream of the numbers, and that is the computation that must be performed on the larger set of the input values. And the minimal clock period which is necessary to ensure the correct evaluation is T minimum is equal to Tc minus Q plus TPD comma logic plus TSU. So these Tc minus Q and Tsu are the propagation delay and the setup time of the registers. Here we can assume that the registers are edge trigger registers. The term TPD logic stands for the worst case delay path through the combination network which consists of the adders, absolute value and the logarithm function. Assume that each logic module has an equal propagation delay and it is active for only 1/3 of the clock period. For example, the adder unit is active during the first third of the period and remains idle. That is, it does not have any useful computation during the 2/3 of the period, which this pipelining can be used for improving the resource utilization and the research and the increase the functional throughput. So here this universal shift register will be connected in the form of the pipelines which we can introduce this registers between the logic blocks, and also this can be cause any computation which can be spread through the number of clock pulses, and this appears for every clock periods and the delay will be calculated based on this. So the computation is performed on the assembly line and hence we are calling as pipelining. And the approach which we are using for the sequential circuits is adders, absolute value and the logarithmic function. So this effectively reduces the value of the minimum allowable clock period, that is T min comma pipe is equal to Tc minus Q plus maximum of TPD comma add TPD comma abs plus TPD comma log. And the latches versus register space pipelines which we are used for constructing using the level sensitive latches instead of edge trigger registers. So here you can come here this pipeline system is implemented based on the pass transistor based positive and the negative latches. The latch based system gives significantly more flexibility in implementing a pipeline system and it can offer higher performance. When the clock and the clock are non-overlapping, correct pipeline composition is obtained. Input data is sampled on the C1 at the negative edge of the clock and the computation of the logic block starts here. So the result which is occurring from the clock can ensure the overlapping in it. When overlap exists between this clock and the clock bar, the next input is already applied to the F1 and the effect is propagate to the C2. So this race develops between the previous input and the current one can be calculated based on the overlap time. And the latch based pipeline circuits can be used in implementing using the CMOS latches. So here this is the operation which we have to discuss in the form of the race free function and it is having implemented in the form of the logic functions. So the reasoning for this above argument is similar to the argument which is made in the form of the construction of the CMOS, and during this overlap between the clock and the clock bar, these latches will be able to simplify the pull-up networks and the pull-down networks. So based on this concept, a logic circuit is styled as a NORA CMOS and also it has the C-square MOS the pipeline registers and NORA dynamic logic function blocks, which is the mixture of static and the dynamic logic. So this clocked in such a way that it is simultaneously evaluated or hold in a position which we call in the clock module. So this ensures the design rules where we can recharge or hold or evaluate based on the clock value. When you are giving the clock value as 0, this logic will be pre-charged and the latch will be in the hold position, and the clock bar logic will be in the evaluate position and latch in the evaluate. Clock is equal to 1 clock bar, clock block logic will be evaluate and latch will be evaluate. Logic will be pre-charge and latch will be in the hold position. So while considering the situation pictured in the below figure, during this pre-charge, the output register of the module has to be in hold mode, isolating the output node from the internal events in the module. Also, we can assume that 0-0 overlap occurs mode. A gets a pre-charge to VDD while the latch simplifies to a pull-up network. It can be observed that under these circumstances, the output changes from VDD to down. So here can I say about the static logic and dynamic register. Keys consisting on this one is a synchronous sequential logic circuits is usually performed in identical mode, fundamental mode, reserve mode, or reset mode. Thank you.